review where we left off. Right here's where we left off the other night. For a school play, there were adult tickets for $9 each. Child tickets for $5 each. We worked one somewhat similar to this, didn't we? Okay. The 400-seat auditorium sold out. The total ticket sales were 2,600. How much of each type ticket were sold? Well, child equals how many of them? And adult equals how many of them? The number of children's plus the number of adult tickets total 400. Okay. Then the children's tickets at $5 each, plus the adult tickets at $9 each, produce sales of $2,600. Okay, that's that standard format that we have. Can someone loan her a piece of paper or two? So we add these. I need to find a opposite pair, so I'm going to multiply this equation by -5. Okay. So I'm going to bring it down here, -5c minus 5a equals 2,000. -2,000. Thank you. Okay, these two cancel. Here I get 4a equals 600. Okay, so then I divide both sides by 4. 4 goes into 60 15 times with another 0 on the end. That's clock math. 4/4 of an hour. Okay, so there are 150 adults. Well, to find the number of children, we go to the top equation. The number of kids plus 150 equals 400. So the number of kids is going to be equal to 400 minus 150, or in this case, 250 children attended. Okay. Questions about working that one? Okay. Find the distance. Distance equals square root of, I'm going to call this 0.2. I'm going to call this 0.1. Okay, so I'm going to take x value of the first one, or of 2 minus x value of that one, square it, plus y value of this one, minus y value of that one, square it. Okay, that equals, in this case, 0 squared plus, in this case, -5 squared, right?
That 3 should be positive.
No,
No.
because remember the formula is y minus, okay? And that's why this one was also minus. Okay. Now you see how numbering these 0.2, 0.1 makes it just fall in real easy in order. Okay, so this in turn equals square root of 25 equals 5. So the distance between these 2 points is 5. Actually, D equals 5. Don't box that whole thing. Questions on either of these two?
Wait,
Uh-huh.
so this one, it doesn't, is this one of the ones where it doesn't matter which one is your P1 or P2?
No, but it's easier if you do them left to right, left to right.
Okay.
You're much less likely to make a mistake if you do them left to right, left to right.
I'm just making sure that, 5 cents.
But it really doesn't matter. You'll still get the same ultimate answer because the only difference is you would have ended up here with a positive 5 squared is 25. Ultimately. Okay, any other questions? Good question. All right. And I think you can read it up there, can't you? Okay, I'll erase this one now. Yeah, no, I'm gonna lower that. I don't want to stretch out my tippy toes. Can you all read that? Okay. Is this one-to-one function? Okay. In other words, what they are asking you is if this is f of x, find its inverse, and then do that compose thing, where you get 1x each time. That's what they're wanting you to do. Now, there's another way to do this one. This one's a line. All lines are gonna be. Okay. All lines are gonna be. And this one is a line. So it will meet those conditions. Okay? Except they do specifically tell you to find the inverse. So what are the 4 steps for finding the inverse? First step is rewrite it with a y instead of f of x. Our second step is to interchange the x's and the y's. Okay. Third step is isolate the y. So I'm going to bring this over here. +5, +5. So I get x plus 5 equals 3y. Now I'm going to divide both sides by 3 every term. Or actually, I don't have to do every term. I can do it like this. Or you can do it every term. It really doesn't matter. Okay, so we now have y equals x plus 5 over 3. So we have accomplished step 3. Step 4 then is just simply replace y with the f inverse notation. And so here would be that answer. Now, it is. One way you can do it is you could graph the silly thing. This one, -5 is your y-intercept, and you go up 3 and over 1, up 3 and over 1, and up 3 and over 1, and you get a line that goes like that. That line passes both the horizontal and the vertical line tests. Okay? This one, if you rewrite it so that it becomes F inverse of X equals 1/3 X plus 5/3, that and that are the same. If I tried to graph it, this is going to make it a little hard. 5/3 is 1 2/3. So if here's 1, here's 2, 1 2/3 would be about there. About. And from there, okay, 1/3 X. We go up 1/3, up 1/3, up 1/3, down 1/3, down 1/3. And you get this line, and it meets both horizontal and vertical. And if you look at these two, they reflect across that X equals Y line, don't they? So the answer is yes. Now, the other way of doing this is if you want to take this value and that value and compose them. Because there is a rule that if you have F compose F inverse of X, and you get the answer 1x that way, and if you have F inverse compose F of X, and you still get 1x that way, that they are 1-to-1. Now, the rule is you try this one first. If you get anything different from 1x, the answer is no. And you don't have to do this part. Okay? If you try this and you get that, you still have to do that to prove it. So I'm going to go ahead and do that for you. I'll just have to erase this for the next problem. So for this one up here, that means I'm going to take this equation and I'm going to replace the X with that equation. Okay? Or in this case, X plus 5/3. Well, this 3 and that 3 cancel each other out conveniently. And I get Y equals X plus 5 minus 5. These two cancel out, and I'm left with Y equals positive 1x. Okay. The other way, we take this equation, which I prefer to use this form. Okay, Y equals X plus 5/3. And we're going to replace the X with that other part. Like so. Now, this numerator, I don't really need that parentheses. Y equals 3x plus 5 minus 5 all over 3. Those two kill off, right? And 3 cancel. After that's killed off, I couldn't do this division until after that's killed off. So I've got equals 1x again. Okay. Now, three different ways I've shown you to determine. If you wrote out to me, first you would have to get this answer, this one or the fractional version of it, wherever it is that I did that. You would have to do that. But if you wrote me a statement saying these are both linear equations and all linear equations are 1-to-1, I would accept that at full credit. So that's one way of doing it. If you graphed them and demonstrated by points that they were opposites and that they reflected, I would accept that. Or if you did this, I would accept that. Because all three of those are valid proofs that those are 1-to-1 equations. Okay? Now, you do whichever one is easiest. But remember, all linear equations are 1-to-1. Parabolas, on the other hand, are not. Oh, did I mention something about the vertical and horizontal line graph thing on the fraction on the graph
Yes.
parts? Because I should have if I didn't. Okay, number 24. The difference between two positive numbers is 9. One number is 3 less than 4 times the other. What are the two numbers? Okay, we hit this very briefly one night. If x is the first number, then because this says they're positive over here, okay, and then our other one, we've got y equals obviously our second number. Now, the difference between these x minus y, the difference is 9. There's one equation. Okay. Now, for the second equation, one number is 3 less, or 3 taken away from 4 times the other. Does that make sense? One number is 3 taken away from 4 times the other one. I have 2 equations. How are they wanting you to solve this one? by substitution, because they've got an isolated value already. Okay? Now, I arbitrarily chose to put the X here instead of putting the Y there. It doesn't tell me whether it's the first or the second, so it doesn't matter. So this becomes my substitution value. So I take the other equation, X, and I put that substitution value in there. Minus Y equals 9. Or in other words, 4Y minus 3 minus Y equals 9. And these two, this one gives you 3Y here. Actually, I should show plus. No, it doesn't. It gives you 5Y. No, it doesn't. They're on the same side of the equal sign. I better watch what I'm saying. I'm just going to move it over here and add them. I end up with 3Y. Minus 3 equals 9. Take that over, plus 3, 3y equals 12. So y equals 4. First answer. Second part of this is I've got to find out what x is. Well, I can use this one right here, or I can use that one. They're both about equally easy. I'll go ahead and use the second one. So x equals 4 times 4 minus 3 equals 16 minus 3 equals 13. X equals. So that, and if they tell you to put it in a point, then your answer would be 13.4. If they tell you to put it as a point coordinate. Even if they don't tell you, if you put it this way, they won't count you wrong. Question on this one. Okay. This goes way back to that first night of class when we talked about clue words, doesn't it? So you guys didn't know I was getting ready to be ready for the final on the first night, did you? Find the midpoint. What is special about the midpoint formula? It's the only one where you add them instead of subtract them. Remember on the difference formula we subtracted? And on the circle we subtract. But this one we add. Because what we're doing is we're averaging the x's and averaging the y's. Doesn't matter which, since we're adding, it doesn't matter which point you call which. Just remember this is x, that's y, that's y. So you don't intermingle them. Okay, so we have -4 plus +4 over 2, because there are 2 of them. And as a separate problem, we have 2 plus -3 over 2, because there are 2 of them, which is going to make our point. 4 minus 4 is 0 over 2. 2 minus 3 is -1 over 2. So ultimately, your answer is 0, -1/2. Any questions on this one before I go on? Anyone need me to not erase yet? Find the slope-intercept form of the equation of a line through the point -6,3 with the slope of that. When you see find the slope-intercept form of the equation, you need to remember the point slope formula. What is the point slope formula? Y minus y1 equals m times x minus x sub 1. What is x? What is the sub 1's? Eat that point right there. This is point 1. So this is x sub 1, that's y sub 1. And we've got the slope over there. So we've got y minus 3 equals the slope 1/3 times x minus -6. Y minus 3 equals 1/3 times x plus 6. Just cleaning it up a little bit. Very frankly, if you were doing this on your own paper, I wouldn't care if you just did that instead. Okay. So now we have to distribute this. Y minus 3 equals 1/3 x plus 1/3 times 6 is 2. Okay. Now we add this 3 to both sides to get it over there. Y equals 1/3 x plus 5. Done. And you've got a handout page with that formula on it. Actually, you've got a handout page, I think it's page 30 in your packet, that has almost all of these formulas on it, which might be a good thing to have open as we're doing this tonight. Okay, variation. Remember, the most fundamental one of these is y equals kx and y equals k over x. This one being inverse variation, that one being direct variation. The word proportional means the same thing as direct. Okay. So if x, now watch out. I've taught you this, but they are listing this one, x is. So you can't do y is. Okay, you gotta watch what it says. By the way, because they're putting the x out front, that means they're giving you the inverse of one of these. But anyway, okay, it is, x is directly proportional to the square of y, ky squared. The square of y. Now, that's your equation of variation. Now, let's solve for k. If x is 27 and y is 3, okay, we find k. So 27 equals k times 9. Divide both sides by 9. And we get k equals 3. So that changes this to x equals 3y squared. And you need to show that equation. Now that you've shown this equation, we can solve this final part. Find x if y is 4 instead. Okay? And order of operations matters. That square has to be done before the 3. So x equals 3 times 16. And x equals 48. Okay, let f of x equal 5x cubed minus 3x squared minus 3x minus 4. Evaluate f of -2. What does that mean? That means replace x with -2. So we've got 5 times -2 cubed minus 3 times -2 squared minus 3 times -2 minus 4. Okay? Remember, this cube only applies to that. And we got to do powers before we do multiplies. So we've got 5 times -8. -2 times 2, -2 is positive. 4 times -2 is -8. Minus 3 times positive 4 minus 6 minus 4. So I've got 5 times -8 is -40 minus 12, what? Where?
It should be a positive.
-2, no, stop. -2 squared,
Yeah, that's.
The next one's over.
this one?
Yeah.
It is oh, yes, thank you. Good catch. Okay, this one, do you agree is minus 12?
Yeah.
Okay, and these two make 2. Okay. So that makes negative 52 plus 2 makes negative 50 is f of negative 2. And I want it labeled that way. Some of you have gotten sometimes lazy and I haven't taken off points and just put down negative 50. I want to see your label on that. Okay. I'm trying to keep this writing underneath that hot spot on the video. I actually might be able to enlarge this ever so slightly. Not that much. Well, a little bit anyway. The sum of 3 consecutive integers. Okay. What does that, what does consecutive integers mean? That means like 4, 5, 6. Or negative 2, negative 3, negative 4, that would be reverse order. Okay. Now, let's let x equal the first. What's the second one gonna be? These are even numbers. They jump by 2s, actually whether they're even or odd. Okay, from 3 to 5 is a jump of 2. From 2 to 4 is a jump of 2. So our second number, x plus 2, will be our second number. But it says I got 3 of them. Well, if this one's the first one, 2 more is the second one, 4 more is the third one. 2 to 4 is 2, 2 to 6 is 4, equals third. So that's your reasoning in this. Okay. Now, the sum of these, first one plus second one plus third one is 48. There's your equation. You just got to read it step by step. Okay, look for that verb because that verb is always the equal sign. Now, we can solve this thing. We really don't need these parentheses. Let's add all the x's together. Let's add all the numbers together. 2, 6. Let's take the 6 over to the other side. Let's divide by 3 on both sides. And we get x equals 14. Now, that's the first number. It says, don't just find the first number, integers. Means we got to find all 3 of them. So let's go back to this. Equals 14. Equals 16. Equals 18. And then box this. See why I set the problems up this way? Because it gives you your labels. Well, I mean, these are problems like previous final problems. These are our citation problems, basically. Okay, can I go on? What?
Freezing.
Yes, I agree. Why do you think I'm up here dancing around? So I can stay warm.
Unless you have the one in shorts.
That's your.
That's your.
This time of year,
That's your
no
fault.
pity. No pity for wearing shorts this time of year. Although I had to wear them the other day when I had a doctor's appointment. Okay, because they had to look at something on my leg. All right, for the quadratic equation of this. Now you got to read what they're asking you. You start doing some stuff you don't got to do. Pardon my French or bad English. Find the discriminant. Remember, this is the part underneath the radical. And because it's the part under the radical, if you get a negative number when you're all done, then it's going to be a pair of imaginaries. Okay? If you get a positive number under here, then it can either be real numbers or irrationals. Or one real number, if it's 0. So, the discriminant in this is B, and that is A, that hidden 1 right there, and this is C. So B squared, -5 squared, minus 4 times 1, times C, which is -1. This gives me 25, and this gives me +4, which is 29. Now, if I put that radical back on top of it, and remember I've got a negative b out here plus or minus an AC down here on the quadratic formula, okay? But what is that going to give me? It's not a negative. It's not a negative. It's not 0, so the answer isn't one real number. Okay, those are the two easy ones to rule out. And this is not a perfect square. This is not a perfect square. That means you can't take the square root of it and get a real number or rational number. So your answer is 2 irrational numbers. Now, part B. How many solutions does it have? I've already answered that. 2. And are they real or imaginary? They are real, even though they're irrational. Because irrational is a weird form of real. Everything is real that's not imaginary. So that's your answers on that one. Does that make sense how we went through that? Technically, this is the only part that's the discriminant, but to analyze it, you need to remember that that's got to be over it to figure out these rules. I've got paper towels up there, whoever's doing that stepping and starting. Feel free to use them. That's what they're there for. Some people call them paper towels, really, they're nose paper. When I used to teach junior high, I had a toilet paper dispenser hung on the back wall, had a sign above it, nose paper. some kids would come in out of a Kleenex box, grab half the box, one blow and throw it. So I put the toilet paper roll up there and made it much more functional. Okay, graph the equation on the axes below. Ooh, there's some nasty stuff in this one. Let's see, this is gonna go up to, this is going to go right to 3. Okay, and this is going to flip across the x-axis. Okay. Now, what kind of an equation is this? This is a quadratic equation in vertex form. Okay, that number and this number tell me the vertex. I can't write there. That's where the hot spot is. The vertex equals the point +3, opposite of sign, and of sign. Okay. Now, if this were positive, what direction would this graph go? It would go up. But this is negative, so it's going to go down. Okay, so the point 32, there. 1, 2, 3, up 2. Right there. Oops. 1, 2, 3, up 2, yeah. Okay, there's a vertex. So we know this thing's got to come down like this, okay? We also know that this is the axis of symmetry. And it's got to match distances this way and that way everywhere. Okay? Now then, what other thing might be handy to have? The y-intercept. How do we get the y-intercept? Let x be 0. Okay? Yes, it would. So if that is the y-intercept, what's x got to be? Okay. 1, 2, 3, 4, 5, 6, 7. Almost ran off my paper. Okay. Now, does this tell you to find the x-intercepts? No. You could. It'd be a bother. It only tells you to graph it. Now, because of that, if you know that this is 1, 2, 3 spaces from there, then it's got to be 1, 2, 3 spaces from there. Right? So basically, this thing is going to go like that. And because it only says graph, you don't absolutely have to find these 2 points. Except I drew this kind of bad right through there. if this is 1.5 over that way, it better be 1.5 over here. And come through like this. Okay. Because it's got to be symmetric. Okay. Now, if it said find the x-intercepts, or if it said find the solutions, or if it said find the roots, or if it said find the zeros, then we would actually have to find the x values. Okay.
Which one would be?
Well, the formula you would use on that one is I would multiply that out, add 2 to it, and then use the quadratic formula or factor it. Multiply this out. Okay. X minus 3 times x minus 3 is x squared minus 6x plus 9 plus 2 y equals, or actually 0 equals. Then we would have minus x squared plus 6x minus 9 plus 2 equals negative x squared minus 6x minus 7. Okay, plus 6x, yes, thank you. There. And then you can either factor this or use the quadratic formula. Actually, if it weren't for that negative, you could pull the -1 out, have x squared minus 6x plus 7 like that. And this factor is actually pretty easy. Okay, it factors in the -1 times x minus 7 x plus 1. Okay, or you could use the quadratic formula, yes.
Can you just plug like random numbers into X?
Could you make an XY table? Well, yes. But what you'd have to do is choose Y to be 0 and figure out what X is, which is what I'm doing here. This is how you would do that.
So can I plug like 1 in for
You could
X?
try it and you could get a whole bunch of points. But if the problem asks, what are the roots, the solutions, the zeros, then ultimately you're going to have to find out where this X or Y value is 0 to get the x-intercepts. Okay, so anyway, we get x equals 7 and -1. Here, -1, it actually goes right there. Here it goes right there. So I'll redraw my arc. Comes out here like this. Comes out here like that.
Yeah, it looks like it's
Yeah, kind of. Not a very smooth curve there. Now, they did not ask you to do this on this problem. It's possible they could. Okay, and if this won't factor, then you can always throw it into the quadratic formula and get those two numbers. Okay. Graph the inequality. Okay. On the axes below. Anytime you got a problem like this, an inequality, first thing you want to do is put it in slope intercept form. Y equal mx plus b. So in this case, negative 5y less than or equal to negative 2x plus 10. I took that over there. Okay. Divide by negative 5. Divide every term by negative 5. And flip symbol. Remember, when you divide or multiply by a negative, you have to flip symbol. Now, continuing. This gives me y greater than or equal to positive 2/5 x minus 2. That's my new equation. Okay. Negative 2. Right there. My y-intercept. I'm going to go up 2 over 5, up 2 over 5, up 2 over 5. Up 2 over 1, 2, 3, 4, 5. Up 2, 1, 2, 3, 4, 5. Down 2, 1, 2, 3, 4, 5. And consequently, I have my line. Now, is my line going to be solid or dashed?
Solid.
Solid because of that or equal. Okay, so I draw my line. Solid. Now, the last part of what we've got to do is analyze which side of that line we shade. This says y values bigger than the line. Everything up here. Or if you want to draw arrows this way, you can, or, you know. But you shade that side of the line. Questions on this one? Do I need to wait a moment before I erase? Look at this problem number. Now, there have traditionally been 32. I have heard a rumor that the test maker screwed up and had to delete 2 questions, and there might only be 30 on the test if you didn't replace the 2. If it is, it is. Okay. Count on 32 though. That means you got about 3.5 to 4 minutes of problem because you got an hour and 50 minutes to work the test. Because we will start promptly at 1 o'clock. And if you're late, like some of you come in here late, then you have lost time. Now, don't get in a rush to leave because we're not done.
Yay!
I got another set of 50 problems.
50?
That's what I said. Again, these are more lookalikes. We're going to do these slightly different than we did the first 32. Okay, in the first 32, whether they seemed easy or not, I didn't work them. Now, on these, and we'll do some of them tonight, and then we'll do some of them Thursday night. Okay. On these, if everyone wants to skip it and go on, we will. But if even one person wants to see it work, we will work it. We meet. Okay? So that's the way we're doing this part. Okay, this question right here. I'm going to see if I can enlarge it a little bit. I can get away with that much. Nah, probably not. Probably better stick with that. Okay, so anyone need to see this one work? Okay. Basically, you distribute. The biggest thing is don't forget to distribute that to both of these. Yes. No, I do not intend to send this to you. Although you can watch it on video for 3 days. Or 4 days, I think it is. It'll disappear from YouTube in 4 days, on Friday. Okay, so second problem. Look what we got here. Anyone need this one? Yeah, I thought so. Lots of people missed this one when we did this. Okay, when you got this situation, you got two problems. Okay. You got this side. Okay, whoops, didn't give myself enough room. -6 less than 3x minus 1. And you got this side, 3x minus 1 less than 5. Okay. And then we just have to work these two problems. Well, let's take this over to the other side, +1 + 1. So we get 3x. Symbol still stays the same so far anyway. And we get -5 here. Divide both sides by 3. And we get x is greater than -5/3, or x is greater than -5/3. This is the one we're going to use if we try to graph this thing. Always with the variable on the left if you graph. Okay, this side. +1 + 1, 3x less than 6. Divide both sides by +3, x less than 2. Okay, so we've got these two answers. Okay. What that means on the number line, here's 0, is here's -5/3, which is 1 2/3. Here's 1, here's 2, here's 1 2/3. And here is +2, 1, 2, right there, 2. Now, what is this saying about these? This one is saying that its numbers less than 2. That way. What is this one saying? This one is saying its numbers greater than that one. So what's my solution then? Everything from here to here. So in interval notation, our answer is -5/3 to not inclusive, because there are no gaps in this piece. Okay, and here is obviously our graph, although the problem didn't tell us to graph it. It's much easier to get the interval notation if you graph it. Say again. This would be your answer in this case. The internal interval, easy for me to say. Did you have a question?
Yes.
Go ahead. The dots. Oh, here?
I don't know.
Well, in grade school, yes, those would have been open circles because we use those in grade school. In college algebra, you will have to use the brackets and parentheses. So I'm wanting you to get used to it. Okay. And by the way, welcome to Frida, right? No, wrong name. I've got you confused again, don't I? I have a student in my online class who said she might come tonight. And they're dead ringers for each other. Doppelgangers, I think they call that.
Yeah.
Okay, well, any questions on this one? Did I answer yours? I answered yes, but don't do it. Don't do that, that's contagious. Okay, here we go. Absolute values. What happens when we have absolute values? Two problems again, a plus or minus. Here's the plus side, here's the minus side. 4x minus 3 equals 11. And 4x minus 3 equals negative 11. Okay, so plus 3, 4x equals 8, divided by 4, and x equals 2. Okay. Over here, plus 3, strange looking plus, 4x equals negative 8.
Yeah, you did that wrong.
Where? Oh, yes, this should be 14. Thank you. Yeah, I did that on purpose to see if you were paying attention. Right. Okay, so 14 divided by 4. Now this problem gets ugly. Equals 7/2. Or 3.5. Okay. Well, now I can try to continue over here since I'm so distracted now. I think I'm right this time.
Yes.
Okay. So I've got those two statements. Now, what do I do with those? Well, if they ask you what are the two solutions, you could write x equals 7/2. That's a 2, comma, negative 2. You could put them in braces, 7/2, negative 2, like that, and either of these two answers would be accepted.
What if it doesn't have the wording, it just has the top?
Like that.
That would be your final answer. Okay. This is an equal, so these are specified points, not a range, like if you have less than or greater than. Yeah, like the problem below it. This will probably be the last one we do tonight. I'm guessing, unless you guys just really want to do the next one after that. I mean, we don't have to do this one if you don't want to. It's up to you. Okay, let's do this and we'll go on. Okay, anyone want to see this one? Yes, did I hear a yes? Okay, good. All right, so two problems once again. 6a plus 2, oops, I'm going to spread this out. 6a plus 2 less than or equal to 8. Here's the important part. 6a plus 2 greater than or equal to negative 8. Here's the minus side, here's the plus side. Remember, on the minus side with less than or equals or greater than, you got a flip symbol on the minus side. So that's the critical step in this problem. Plus 2, 6a less than or equal to 10. Okay, divide by 6, divide by 6. A less than or equal to 5/3. Okay.
You should have subtracted.
We did it.
Did it again, didn't I? Okay, well, let's make that a 6. Actually, it's going to make this a much nicer problem. Much nicer problem. Okay, over here, minus 2, 6a greater than or equal to negative 10. Divide by 6, divide by 6. A greater than or equal to negative 5/3. Okay. Now, we can't just write 1 and negative 5/3 like we did the other one because these are inequalities. So we have to do an interval notation. And the easiest way to do that is to graph them. So this one, here's 1. And this is greater than or equal to 1. So, or less than or equal to 1, I mean. So brackets, arrow this direction. This one, here's positive 1 or negative 1. Here's negative 2. Negative 5/3 is 1 2/3. Okay. It's got the or equal and it's telling us is everything bigger this way. So then our solution is that graph. So that tells us what our interval looks like. Negative 5/3 and 1 box.